In this video, we're going to talk about the elasticity of demand. This is a topic that you will have seen in your econ classes, but now that we've got some calculus under our belts, we can see where the concept comes from. Okay, so the background of elasticity of demand is to try to understand when will a price increase lead to an increase in revenues. And economists talk about the elasticity of demand, the percentage change in quantity demanded for a 1% change in price. Okay, so first we need to talk about the relative rate of change. So the relative rate of change of a function, f of x, is defined as the derivative of the natural log of f of x. Now, if we take the derivative of the natural log of f of x, again, the chain rule gives 1 over f of x times the derivative of f of x, which is f prime of x. So this equation becomes f prime of x divided by f of x. And if we think about it, right, this is the rate of change of the function. But depending on how big the function is, an f prime of x being 10 could be a very big number, it could be a tiny number, right? If f of x is 1, then f prime of x being 10, it's a large number. But if f of x is 1,000,000, then f prime of x being 10, it's a relatively small number. So f prime of x divided by f of x is the relative rate of change of a function. Let's do an example. So find the relative rate of change for the function f of x equals 4 times the square root of x. So I'll rewrite that to make our derivative a little easier. So that's 4x to the 1/2. And so f prime of x equals 4, bring the constant out, times 1/2 x to the negative 1/2, which is 4 times 1/2 is 2, 2x to the negative 1/2. Okay, so the relative rate of change is f prime of x divided by f of x equals 2x to the negative 1/2 divided by 4x to the 1/2. X to the negative 1/2 is 1 over x to the 1/2, so that's going to be 2 over 4, so 1 over 2, x to the 1/2, x to the 1/2, which is 1 over 2x. So our relative rate of change is 1 over 2x. So for any particular value of x, plug it into this equation, we get a relative rate of change. Okay, if $10,000 is invested at an annual rate of 5%, continuously compounded, then what is the relative rate of change of the amount in the account? Okay, well, the amount in the account, the future value is 10,000 e to the 0.05 t. Okay, so we need to take the derivative of this function. Future value, the derivative, is 10,000, that's a constant, e to the 0.05 t times 0.05. All right, because we multiply that out. Now, I'm not going to bother multiplying all these things together. This was a chain rule. So future value prime, the derivative divided by the future value is 10,000 e to the 0.05 t times 0.05 divided by 10,000 e to the 0.05 t, which is simply 0.05. So the relative rate of change of the amount in the account is 5%, which is exactly the annual growth rate of our account. Again, this 5% comes out in part because this is compounded continuously. If you compounded with a different frequency, for example, future value equals 10,000 times 1 plus 0.05 divided by 2 to the 2t, we of course will get a different answer. So elasticity of demand. Let the price be P and the demand be X for a product, and let's assume they're related by a price demand equation of the form X equals F of P. Then the elasticity of demand at price P is E of P is the relative rate of change of demand, negative relative rate of change of demand divided by the relative rate of change of price. Now, we can do a little bit of work. Negative relative rate of change of demand divided by relative rate of change of price is ddP of ln of f of p divided by ddP of ln of p, the derivative of the natural log of f of p divided by the derivative of the natural log of p. We take both of these derivatives, f prime of p over f of p, divided by 1 over p, because we're taking the derivatives with respect to price, equals negative p f prime of p divided by f of p. So this is our equation for the elasticity of demand. Now we relate this to revenue. So remember, revenue is x times p, which of course is f of p times p. Now we're going to take the derivative. So the derivative is, again, this is a product rule, so it's derivative of the first function, so f prime of p times p, plus the first function, f of p, times the derivative of p, which is just 1. And now we're going to do a little bit of work. So take the first term, multiply by f of p over f of p, which of course is just 1. And then we're going to factor out f of p. So we've got an f of p in both terms, so that factored out, times 1 plus p f prime of p times f of p. And this quantity, p f prime of p f of p, is the opposite of elasticity of demand. So the derivative of revenue with respect to price is f of p times 1 minus e of p. Okay, well, we know f of p is bigger than 0, right? Because demand has to be positive. So the sign of the derivative of revenue with respect to price depends on the elasticity of demand. And there are 3 situations. Situation 1, E of P is less than between 0 and 1. 2, E of P equals 1. And 3, E of P is bigger than 1. Okay, those are our 3 possibilities. First off, actually, E of P equals negative P f prime of P divided by f of P. Okay, price is positive, demand is positive, so these 2 quantities are positive, but demand should go down as prices go up. So E of P, this f prime of P is negative, which means E of P is positive. Okay, so that's why that 0 is between E of P is less than 1. Okay, let's look at this first case. 0 is less than E of P is less than 1. If we go back down to the revenue equation, we see that this quantity, 1 minus E of P, is positive. So what does that mean? That means that if prices go up, revenues go up. So that's the first case. Second case, E of P equals 1. Well, when E of P equals 1, then R prime of P, the derivative of revenue with respect to P, the price, is 0, which means that when prices change, revenue does not change. E of P is bigger than 1 means that 1 minus E of P is negative, which means that if you increase prices, revenue is going to go down. So, inelastic demand, if 0 is less than or equal to E of P is less than 1, then we have inelastic demand, and that means a percentage change in price produces a smaller percentage change in demand. It's the ratio. And from a revenue perspective, you expect a price increase should increase revenues. So that's called inelastic. Elastic is E of P is bigger than 1. A percentage change in price produces a larger percentage change in demand. Of course, increasing price means the demand goes down by more, in which case, from a revenue perspective, if you increase prices, your revenues should decrease. And unit demand is when E of P equals 1, percentage change in price produces the same percentage change in demand, and from a revenue perspective, you expect a price increase to be neutral to revenues. So a small price increase won't change your revenues. Okay, so an example. We have our price and demand. Price is P, demand is X, for a product related by this price-demand equation. X plus 500P equals 10,000. We want to find the elasticity of demand and interpret E of 4, 10, and 16. Okay, so first off, we need X to be a function of P. So we're going to go X, rewrite our equation, equals F of P equals 10,000 minus 500P. All right, so now we've got our equation in the correct form. So we want to find the elasticity of demand. Okay, well, that's going to be elasticity of demand equals negative P F prime of P divided by F of P. Okay, so F prime of P, I'll write it over here, F prime of P equals negative 500. Okay, so this is equal to, we've got a negative sign, we've got another negative sign, so that's 500P divided by 10,000 minus 500P. Okay, so that's our equation for the elasticity of demand. E of 4, so when the price is 4, we have 500P. So 500P, 500 times 4 is 2,000, divided by 10,000 minus 2,000 is 8,000, equals 0.25. So this is inelastic. If we increase prices from 4, we're going to increase revenues. E of 10 is 500 times 10 is 5,000 divided by 10,000 minus 5,000, which is also 5,000, which is 1. So this is a unit demand, which means that when prices increase, revenues don't change. And then E of 16 is 500 times 16, which is 8,000, divided by 10,000 minus 8,000, which is 2,000. So it's 4, and this is elastic demand. And what does this mean? This means that if we increase prices, revenues are actually going to go down. So we can see for these three values, 10, 4, 10, and 16, we've got an inelastic demand. We increase prices, revenues increase. Unit demand, we increase prices, revenues stay constant. Elastic demand, we increase prices and revenues fall.